during the pandemic, we're going to have to change some things a little bit, but we'll do our very best to make sure this is a good time for you to really learn some of these fundamentals of how these systems work and hopefully build some real computer vision systems. So let's just do TA introductions real quick. So on the line with me, I have Arvind and Rohan. So Arvind and Rohan were both students in my class last year. They both did a really great job. That was before we had the pandemic, which is hard to even think about life before COVID. But they've been working really hard this summer, getting material ready for you guys. They really are kind of your first layer of help. I'm here to help as well, but I'm just a little bit, I've got a tight schedule this fall. So really Arvind and Rohan are your first support. And they really know their stuff. So I'm really happy to have them on board as TAs. Do you guys have anything to add? Thank you for being here and getting everything set up. Maybe if you guys could just say a quick hello, that'd be great. And then maybe just a very short introduction. Maybe just a little bit about how long you've been at UNCC and just a little bit about your background. Not to call you out.
Arvind, if you want to start.
Yeah, you can. So you could start, Rohan.
Guys, hello, I'm Rohan. I've taken this class last fall in 2019, and it was pretty great. Your professor used to take classes were in person, and we had a great experience with it. We are looking forward to how it goes online this year, but I hope it's great and it will be a great experience for you guys. Yeah.
Hello everyone, my name is Arvind. I took computer vision last semester on fall 19th semester. It was a great experience with all the assignments, quizzes, and the project. This time the scenario is a bit different because of the pandemic. We are missing in-person classes and interaction, but still we'll make sure everything runs smooth and it will be a good semester for you guys.
Great. Oh yeah, thanks guys. Sorry to put you on the spot. I didn't give them any warning. But yeah, thanks guys. Awesome. Yeah. So yeah, the TAs like Arvind and Rohan really help make the class work. So I'm really grateful to have them working on the team. And again, yeah, please reach out to them with any questions. So as I go through this first lecture, with WebEx in general, we're still clearly working out some of the kinks with WebEx. But in general, if you have questions, please chat them. Rohan and Arvind will be monitoring the chat, and they will just ask me, and we'll talk through your questions. So yeah, if you have any questions as we go through, please put them in the chat, and we can use this time to really just like we would in lecture to discuss any questions you have. So with that said, let's go ahead and hop into the course overview. So let's kind of figure out what you're going to be learning this semester. What is this course all about? What is computer vision? What are we going to be talking about? So let me go back over here. And again, just real quick, just in case you forgot. So if you want to get to all the course materials, just go to github.com/UNCCV, press enter, and then just go to the UNCC course overview, and that will get you to this landing page. So let's go down and let's kind of talk through what we're going to be learning this year. So I have a little bit of text here kind of describing kind of some of the problems in computer vision. And maybe I'll just talk about it just for a minute. So, and I promise we'll get into some more meat in a second. But just for a second, you've just started this new class called computer vision. And let's just take a second to think about those words, right? So computer vision, if you think about the two words, it's kind of similar to some other words that are kind of popular today or phrases. It's kind of similar to the phrase artificial intelligence. And it's kind of similar to the phrase machine learning. And what I mean by that is that in all those cases, you have the first word, the computer, is something, something we program, it's a piece of technology. And the second word, in all those cases, is something that humans do, right? So, and please let me know, Arvind and Rohan, if I have any audio issues. I'm having to look over here and talk over here. So let me know if my audio is faint and I'll adjust. But in all those cases, right, we have a computer word like computer, and then we have a human word like vision, computer vision, artificial intelligence, machine learning, right? And I think it's really interesting because what we're going to try to do in this class is we're going to try to make computers do something that traditionally only humans can do, right? So it's kind of like artificial intelligence, and there's certainly some things and technologies we'll learn that people would call artificial intelligence. I'm a little bit hesitant sometimes with AI, the word AI, just because intelligence is a big word. And what does it really mean to be intelligent, right? How do you really know your computer is intelligent? So you'll notice some of that in the class, but this class is on computer vision. So if we're going to give computers this thing called vision, this thing that we do, and we can see things, what does that really mean, right? How do we do that? So that's just something, just ponder that maybe a little bit at the beginning of the class. When you see something, when you see my image or my screen right now, what is your brain really doing, right? How does it make that into meaning, and can we program that? I just want to share one quote. So this is from an old computer vision book. It's one of the first computer vision books. And I love this old book. It's really old now. It's from the 70s, but they really got a lot of stuff right. If you're curious about it, it might be in the library, but it's this book by Richard Duda and Peter Hart. But there's this great quote from this book. It says, "Paradoxically, we are all experts at perception, but none of us knows much about it." So just think about that quote for a second. What do you think they meant there? I think if we were in class, I would have people kind of, raise their hand and say what they thought that quote meant. And maybe we can figure out a good way to do that with chat, basically. Actually, let's try it. Let's just try it. Let's see how it goes. So we're figuring out how to best use WebEx and how to best use, the tools we have. So yeah, what do you think they mean by that quote? So just take a minute, and if you have an idea, just put it in the chat window. So paradoxically, we are all experts at perception, but none of us knows much about it. What do you think that these early computer vision researchers back in the 70s, Peter Hart and Richard Duda, what do you think they meant by that? So I'll just give you 1 minute to think about it. And let me see if I can get to my chat window here. Oh, there we go. Perfect. Okay, good. I apologize. I wasn't planning on using the web app. I was planning on, or the native app. I was planning on using the web app, and this is throwing everything off. So we have one answer. We know everything there is to know about it, but there's not much info on it. Okay, sure. Any other answers? We take for granted, that's a good, I love that, right? So yeah, so Sean Hayes says, we take for granted our own ability to see. I love that. That's a really good way to say it. That's really, really good. We also see we are all experts at perception. It means we are pretty good in terms of visualizing things around us. Okay, yeah, around, have any idea how powerful it can be? No one knows the nitty-gritty about what the brain does. Yep, and I see more good ones coming in now. That's great. So yeah, some really great answers there. Arvind and Rohan, when we have a chance after lecture to regroup, let's decide how we want to handle this if we want, because I'm getting a mix of private messages and group messages. Let's decide how we want to, I'm not sure what we should do. We'll figure that out later though, no big deal. So I'm seeing some really great answers here, guys. This is great. So yeah, so I think what I would say is that, we have this amazing computer, maybe it's like a computer, maybe, in our brains, and it helps us see, but we don't really know how it works because we just get to experience kind of the output of it, right? It's not, you can't just look in your brain and figure out how you're seeing. And I think that'll become really apparent, I hope, in this first challenge. So let's see here. So that's just a little bit of background, what we're going to be kind of doing in this class. And let me just say one more thing about it, and this will become really clear in this first module. It's taken a while to really get computer vision systems to work well. And really, people have been working on it since the 50s, so at least 70 years. But really, in the last 5 or 10 years, we're starting to see computer vision systems that for some tasks are actually better than humans, which is really exciting, right? So this is a really exciting time to study computer vision because we're starting to see systems that can really outperform people, which is pretty crazy. So with all that said, let's hop into our modules here, but I'm going to overview the rest of the course first. But we're going to hop into our first module shortly, the original problem. Before we do that, though, let's finish kind of an overview of the course as a whole. That was just a little bit about computer vision, and we'll get way more into it when we get into this first module, and I think we'll have time today to dive into it. Before we do, let's talk some more about the course, though, some of the details. So if I go back to the schedule here, you can see that it's broken up into modules. So the first module is called the original problem. It's going to take us about 3 weeks to cover, 6 lectures. Then we have a module called Learning to See, a module on neural networks, a module on autonomous driving, a module on deep learning, and then a module on 3D computer vision. So there's 6 modules, and you'll find that the assignments and everything really follow the modules. So you'll see that when you're looking at the material. If I pan over here on our schedule, you'll see your first assignment that will be due. So for each module, you'll have a quiz, and you'll have a programming challenge, and we'll get into those details more. But go ahead and mark on your calendars that the first one is due on Monday, September 28th at midnight. So that gives you about 3 weeks, I guess maybe a little less. No, actually right around 3 weeks. So just mark that that's going to be your first thing that's due. And the class is broken up into modules, like I said. The schedule, like I pointed out, this really is your main place to go. When you're getting ready for the lecture, please go here and look at what reading is required. So we have some required reading before next lecture. So here's a link to the reading. If you're interested, we have additional reading every week or some weeks. And then we have a link to the lecture materials. And we'll cover more about how to get to those lecture materials and how to run them. We'll get into that soon. But that's the schedule. So really this Google Sheet, if you have any questions, please look at this Google Sheet first. One other comment is if you move over here, you'll see some notes. Then you'll also see when we have office hours, and then we also have group meetings sometimes, and we'll talk about that shortly, but we also have office hours here for myself and then for our TAs. So that's the schedule at a high level, and we'll get back into kind of going through the syllabus and discussing some of the goals for the course, how grading is going to work, things like that, our collaboration policies. Before I do that, I just want to pause for a second. So you've seen the schedule. Any questions about the schedule? So if you have any questions about the schedule, please just throw them in the chat, and we'll address them here. But do please have a look at it. That really will outline, what your major assignments or what topics you're going to be covering. It's all there in that Google Sheet. So I'll just take a drink of water while you guys think about any questions, and then we'll get into more of the syllabus. Arvind and Rohan, anything else to add to that review of the schedule? Did I miss anything?
No, I guess, Professor.
Okay, great. And feel free to hop in.
Yes.
Okay, great. Thanks, guys. Cool. Okay, excellent. All right. So let's go ahead and let's go back to our schedule here. All right. And this view is terrible. All right. I had a good camera set up. It was going to be great over here, but it's not. Yeah. All right. Okay. So let me just talk about some of my goals for you. So today is, the first day of the course. And we'll be done in it's going to go fast, in about 2 or 3 months. I guess about 3 months, this course will be over. And what do I hope that you have learned by spending time and taking your time and energy to work on this material and to learn computer vision with our guidance? What are we hoping for you? So here are the 8 things. And we're trying to do our best to really grade you on these, right? So this isn't exactly how you're graded, but we try to make the assignments, we're going to try to evaluate you on your ability to learn these things. This is what we're really looking for. The first one's going to sound kind of boring, but it's really important. So it's just setting up a Python environment. This might sound easy. Some of you may have had some Python experience before. Some of you may be new. But setting up a Python computing environment on your computer and getting all the dependencies installed, some of you are going to hate me. You're going to say, Professor Welch is terrible. I hate this guy. Why is he making me do this? But this really is a good skill to have. There are services now like Google Colab that kind of set everything up for you. And we may use some of that later in the course or something, but being able to set up your own environment to run Python on your own computer is something that's really valuable, and this is a graduate level class. So this is something that is expected, and you'll have to do it to complete your first programming challenge. And just know that if you're having trouble, getting a certain line of Python to run and runs on your friend's computer, that's super normal, right? So that's super normal, right? So don't be too concerned about that. It's just going to take some time, so just be patient. When I was first learning Python, I think it was about 8 years ago, something like that, I would lose, 4 or 5 hours to trying to set up some configuration thing, and that's okay. It's just going to take some time. The best way is just to hack through it. So that's the first thing, the first goal for you. The next one is to implement key computer vision algorithms in Python to solve real computer vision problems. So another hope that I have for you in this course is you start to see that, hey, the world is full of interesting computer vision problems, especially today, since we all have, we all have cameras in our pockets, right? We all have smartphones. So there's just a million cool problems that we can address with computer vision. So, and in this class, you're going to be making algorithms that do real things with images from cameras. So, I think that's a really exciting part of the course, and I hope you're looking forward to it. So the next item here is train and validate machine learning models to find database solutions to computer vision problems. So we'll talk about this a ton in this course. I think by the end, we should all have a good understanding of what I mean by database solutions in machine learning. Basically, at a really high level, there's two ways you can design a computer vision algorithm. And let me put the TAs on the spot, just so I'm not talking the whole time. Do you guys remember from last semester, right? What are the two big approaches? There's this kind of approach and this kind of approach. What are those two big approaches called?
Are we talking
Can you guys hear me?
Yeah.
Yeah, no problem. Yeah, so remember we have the empirical solutions, and then we have analytical solutions. Do you guys remember that from, we'll get to it kind of in the third module.
Yes, bro.
Okay, awesome, cool. So anyway, we'll get to this in some more detail here, but at a high level here, basically, we can either write a set of rules to solve a problem, which is kind of what you'll be doing at the beginning, or we can actually train a model to learn an algorithm, which is really interesting. So we'll spend a lot of time on that. Machine learning is a big part of this course. Okay, so the next one I have for you is interpret algorithm performance through measurement techniques and creating visualizations. You'll be doing a lot of this in this course. Debug issues that arise in Python, you're going to be definitely doing some debugging, and the best way to do it is just to hack through it again. It's just going to take some time, and that's okay. Here's what I was talking about a little bit here, the analytical versus the empirical techniques. We'll get into that in more detail. We'll start today with some analytical techniques. And again, empirical means it was learned from data, and analytical means it was designed by a human, basically. So number 7 here is discuss historical and current trends in computer vision. So hopefully another thing that you take away from this course is just a little bit of understanding of where do these models come from, right? Where does these techniques come from? Because if you understand a little bit of the history, I think it will really give you a richer and better understanding of how computer vision works. And I don't think the history part is just for fun. I think that if you know some of the history, you'll be better at computer vision. So it's not for no reason, I promise. And then finally, collaborate with peers and advisors to find and implement solutions to real computer vision problems. So this is kind of alluding to, we'll be doing a big course project. And you'll be collaborating with your peers to find to work on real problems, which is exciting. The project is one of the most fun parts of the course. I know that I'm excited for it. I think Arvind and Rohan are as well. Okay, so let's get into grading a little bit, and please chat if you have any questions here. So here's your grade breakdown. So we've got 30 plus 20 is 50 plus 10 is 60 plus 40 is 100. So these 4 components will create 100% of your grade. And there's only 4 parts. We try to make this class really simple. So the first is programming challenges. So we'll go over this when we have a chance. But for each module, you'll be required to submit some code to solve a problem. You'll submit it to our auto grading server called AutoLab. It will give you a grade immediately. Usually we'll give you 5 to 10 submissions, so you can try again. And that will be 30% of your grade. So we'll get into that in more detail, but you have programming challenges that are programming assignments that you'll do for each module. Each module will also end the quiz. This is 20% of your grade. The quizzes are very short. They're pretty straightforward. It's really just checking if you've understood what we covered in lecture. The quizzes this year will be on Canvas. So in the past, we did quizzes in person, but they will be fully on Canvas this year. The next item is participation. So we'll be using Piazza. And the idea here is this is the place where you can go and ask questions, and you can also answer questions. So you can see how we grade you on your participation here. There's a nice breakdown document that we've prepared for you. So please have a chance to review that, and this will explain how your participation grade will be computed. And please, if you have any questions when you go to start the first programming challenge, or as you start the course, the first thing you should do is go to Piazza, right? So go to Piazza first, see if anyone has asked the same question. That's the fastest way to get an answer. If no one has, then you can ask the question there. While you're there, if you see a question someone else has asked that you can answer, then please do that. That will contribute to your grade. If Piazza doesn't work, then you can reach out directly to the TAs. And if that doesn't work, you can reach out to me. So that's kind of the chain, right? So Piazza, Arvin and Rohan, and then myself. So we're here to help you, but please use that system. So that's your participation grade. In the past, we might have included a participation grade based on something in lecture, but today, the university is planning on having some in person, right? But we are designing the course in a way that in case that the timeline gets pushed back and we spend more time virtually, or if some students aren't comfortable with being in class, or if some students have any symptoms or anything, we wanted to make all the grading flexible so you don't have to be in lecture. So, so the quizzes and participation grade are fully doable online. We would love to do more of this in person, and hopefully things get better soon and we're able to do more in person, but we're trying to, we're planning for the worst and hoping for the best, I would say. So there's no requirement grade-wise that you be in lecture. So both of these will be virtual. All right, so let's see here, the last part. So the biggest part of your grade is the course project. And actually, before I keep going, sorry, Arvin and Rohan, anything to add to that about the breakdown of quizzes and participation? Did I miss anything there about, is there anything you'd like to add there?
No problem.
After the lecture, we would be sending an announcement where students can actually click on the link and join on Piazza. That is one thing. And student Monica wants to know more about the guest lecture.
Oh, okay, great. Yeah, absolutely. Thank you for asking. Okay, Monica got here. So yeah, we need to figure out who's going to be here. But yeah, we have a few different guest lectures lined up. So we have David Deco on 10/24, and then we need to fill in a couple more. I think we've had a few more. So Rohan, I think we've had 3 commits so far. Is that right? We just need to add them to the schedule.
Yes, we got them to the schedule.
Okay.
Yeah.
Yep. So I'm not sure if we have anyone for this slot yet. We'll see. But yeah, so just a little bit about the guest lectures. So by the end of the semester, you guys will be pretty sick of hearing from me. You'll get sick of my voice and stuff. And it's really valuable to have other perspectives on the kind of material that you're learning. So I'm working to line us up some good guest lectures for this semester. So I work in computer vision and deep learning. So a couple of the guest lecturers are people that I've worked with. So David Deco, for example, he is one of the leading experts on computer vision for manufacturing. So you can look him up. Really cool guy. So he's going to give us a guest lecture on using machine vision for all different kinds of applications in manufacturing. Can someone like Lex Friedman or Grant Sanderson come for that empty slot? Sure, yeah, no problem. I actually thought about that. I do know Grant Sanderson, well, a little bit, but maybe I should ask him, actually. That's a great idea. I will ask Grant Sanderson. I love that idea. I'm going to make a reminder, actually. That's an awesome idea. All right, cool. I don't know about Lex Friedman. We'll see. I think he's pretty busy. So yeah, so we'll have various guest lectures. So yeah, great question. I should ask Grant Sanderson. That's a great idea. If you guys don't know, Grant Sanderson has a great YouTube channel called 3 Blue 1 Brown. Really good math channel. I think the problem is I don't know what he would lecture on. I guess he'd lecture on because he doesn't really do computer vision. I don't know. I'll think about it. That would be cool though. That'd be really cool. I like the idea. Okay. Oops, I just deleted that. Haven't I? Okay. Okay. Cool. So anything else on that before I move on? Okay, great. All right, so the course project, this is a huge part of your grade, 40% of your grade. And if you look here, and before I go into the course project, there's something missing from your grades, maybe that's something you would have in other courses. So if you've noticed, there is no test, there's no test, right? And there's no final exam, right? So they don't exist. These basically have been changed into a course project. There's a few reasons we do that. Exams can be good. For this course, I really feel like the best way to learn it is to go do it. So really we're putting a lot of effort and emphasis on the project. we'd rather see you in general spend more time solving problems, than studying for a test. So, at the end of the course, especially like 3 years from now, right? If I think back to when I was in school, I don't remember very much of what I studied for tests, right? So I'd cram and, memorize stuff for the test, and that was okay. But really, at the end of the day, the things that I really remembered were the projects I did, and the things that I really built that I had kind of ownership over. So for that reason, we've shifted the focus here. So no tests, no exams. But I'm kind of making a deal with you. I'm saying, hey, as an instructor, I'm not going to give you tests or exams, but I do expect you to work hard on the group project and to work well with your team. Working on teams can be hard. So sometimes you're going to think it's unfair and you're doing more of the work and this person sucks and I want to be in their group. So my challenge to you is to set that aside and do your best to be a good team member and get stuff done. And I'm confident you guys can deliver some great projects. We've seen some really cool projects in the past, and I'm excited for what you guys do this year. So that's a big part of your project or your grade. If you want to learn more about it, you can click here and you'll see a summary. Let me close these. So please read through this when you have a chance. We'll discuss this more when we have time, but this will really give you some details about the course project. Arvin and Rohan, let's make a note to visit these dates. These are actually, these dates need to be updated. But yeah, you can see some of the basic project criteria here. We will be forming project groups soon, so just stay tuned for announcements around groups, and we'll explain what the format will be like for figuring out who's going to be in which group. So we'll let you know about that in the next week or so. So that's grading. If you have any questions on grading, please put them in the chat, and we will do our best to address them. And I'm just going to discuss just a few last things here before we actually hop into some real computer vision. Okay, so programming. Oh yeah, just so you know what you're up against. So there's no C in this class, no C++, no Java. It's pretty much all Python. So hopefully that's good news to you. For some of you, it might not be. If Python is a new language to you, hang in there. It's got a little bit of a learning curve at the beginning, but it's really probably one of the easiest languages to learn. So don't be discouraged if you're new to Python. Actually, yeah, real quick, Arvin and Rohan, had you guys both done Python before the class last year? I can't remember. Had you guys had any Python experience?
No, Professor, I did not have a Python experience for this class, but
okay.
we had that extra lecture in CHHS where you told us about the basics of Python with CV.
Yeah.
From there it started.
Okay. Do you have any advice for the students who are listening today who maybe do not have a lot of Python experience? Anything that you would have told yourself a year ago? Any advice?
It would be just like don't feel disheartened if you are not able to do it at the first go. Just keep at it, and at the end of the day, you'll be able to accomplish what you want. Python is not that hard to figure out. You'll be able to do it easily.
Great, awesome. Yeah, thanks, Rohan. Fantastic. Yeah. So don't get discouraged at the beginning. It will be frustrating at the beginning. That's okay. Just keep trying. If you keep working on it, asking the TAs, asking on Piazza, we're confident that you can all do well with Python. It's not a crazy language, and there's lots of good resources. Okay, so within Python, we'll be using a number of different libraries and packages. So we'll be using Jupyter Notebooks really heavily. That'll be how we actually write code usually. We'll use a library called NumPy or NumPy, depending on how you want to pronounce it. We'll use Matplotlib, SciPy, scikit-learn, OpenCV, TensorFlow, and PyTorch. So just in case you're wondering, those are the libraries we're using. If you haven't heard of those, not a big deal, don't worry about it, but just in case you wanted to know. Okay, great. So I see a couple questions coming in. So I see a question about industry partners. Yeah, so we'll have more information on that later in the week. So what they're asking about is that in the past, we have done industry partner projects where some groups will work with industry partners with local companies. We are doing that again. Now there are some challenges with coronavirus, right? So we've had some companies are a little bit too busy right now, but we are working on getting that together, and we'll update you on that. So yeah, great question. And then I see a question: what's the biggest challenge in this course? That's a great question. Let me ask the TAs. Do you guys? I have an opinion of which programming challenge I think was the hardest, but you guys actually know better because you've lived it. Which challenge would you guys say is the hardest?
For me, the biggest challenge was managing things between assignments, projects.
Mm-hmm. Yeah, absolutely, definitely. And then I think I'm not sure that what this question what they mean exactly, but of the different programming challenges for each module, do you guys remember which module you thought was the most challenging?
For me, it was autonomous driving.
Yeah. Mm-hmm. Yep. What do you think, Rohan?
The deep learning one.
Oh, deep learning. Okay, yeah. So this is when it'll really start to get difficult. Yeah, exactly. This one is really hard. Yeah. So just start early. That's the advice. Just do not, these challenges you cannot do the night before. Maybe some of you can if you're just, I don't know, if you're a coding savant, but I do not recommend starting the night before. That's difficult. Okay, great. All right, so let's see here. So preparation and prerequisites. All right, okay. So let's see here. The only real requirements are that you know a little bit of calculus. That's not going to be too critical though. We're going to do a little bit of math using linear algebra. Let's see here. A little Python and NumPy is helpful, but you don't have to have NumPy and Python or NumPy. And then I really like the FastAI courses. We'll be using the FastAI library. If you're looking for some resources that kind of complement what we're learning here, I highly recommend checking out FastAI. They have it's all in Python, and they have this great course on deep learning. So if you're interested in diving more into deep learning, then I do recommend checking out FastAI. There's no official textbook for the course. I'm sorry, excuse me. There's no official book you have to buy for the course. There are 4 books that we will reference. So here are the 4 books. So one's called Computer Vision. This one is also called Computer Vision by Prince. There's a deep learning book by Ian Goodfellow and the FastAI book. You're welcome to buy these books if you would like, but they are all available free online. So you don't have to buy anything unless you'd like to. I like owning copies of books. For me, it's a little bit better of an experience, but I'm pretty old, so do whatever makes sense for you. But these are the 4 books that we'll be using, and I believe we have links here. Yeah, to the online version. I think this will link to the online version as well. Let's see. Yeah, great. So we'll be referencing these 4 books. Okay. So finally, let me just share a little bit about policies and collaboration as we get started here. So we want you to collaborate in this course, but I want to give you a word of warning, and I want to make sure I spend a minute on here just to make sure that I'm clear. So if you remember, so your grade is broken up into 4 areas, right? So you have programming challenges where you submit code, you have quizzes, you have participation grade, and you have the course project. Now, these two bottom areas, these are very collaborative, right? So you're encouraged to collaborate. We're not going to be plagiarizing, checking your code or anything like that. We want you to just solve the problem. You can use code from Stack Overflow to help you. That's fine. For these, though, for the quizzes and the programming challenges, these require you to do your own work. So the quizzes, no collaboration is allowed. You have to take this alone. And then programming challenges as well. So you are not permitted to share code on programming challenges. Your code has to be your own. And it's pretty easy for us to check. So we run anti-plagiarism software on your code. And if your code has too much similarities, and the algorithm we run is pretty sophisticated. So even if you change the variable names, usually it will still catch it. If your code matches too closely to anyone from this year or previous years, then we have to report you to the Office of Academic Affairs. So we don't like doing that, but just keep that in mind, right? So make sure your code is your own. And I make this point every year. Every year there's at least a couple students who either forget or they get in a rush and they end up having duplicate code, and we really don't enjoy having to do that. But just know that make sure, as long as your code is your own, you wrote your own code for the programming challenges, you'll have no problem. But keep that in mind. We'll do our best to remind you. But please, yeah, make sure your code is your own. We don't enjoy having to report you or anything like that, but we will if we have to. And it's really easy for us to catch. We just run the software; it finds it right away. So that's our collaboration policy. Okay, cool. I see a few other questions streaming in. I don't have a chance to read them right now. But Rohan and Arvin, if you see any questions that you think are appropriate to discuss here, feel free just to ask me over the audio. If not, we'll address them either the TA or either Arvin and Rohan will chat with you, or we'll get them addressed after lecture, or you can email the TAs if you have a question that's unanswered. But I'm going to keep going. I see some questions coming in, but if any of them look like we should answer now, Arvin and Rohan, just please ask me and then we'll address them now. But otherwise, we'll get them addressed when we can.
Yes, Professor. There's one question by a student. Yeah. It is with self-plagiarism, is it okay as long as we cite it?
With what kind of plagiarism?
Self-plagiarism.
Oh, so would that be if you already had an existing like GitHub repo and you used your own code that you originally authored? Is that how you understand it, Rohan?
Yes.
I see. We haven't had that happen before. That's an interesting question, and I believe that's the question. So if you have code that you've already published, like on your GitHub repo, for example, the only concern then, here's the problem though. Here's kind of the issue that I think about. If another student finds your repo, then they can use your code as well. And then it's going to be difficult for us to figure out whose code it was first, because you could have copied it from them. I would say try to avoid that. Shoot us an email if there's a specific example. When we get to the programming, do this. When we get to the programming challenges later in the course, if there's an example where you really want to use your own code, just shoot us an email and we'll discuss it. But I would say be careful, because if another student finds your repo and uses it, we're not going to be able to tell who wrote it originally. Does that make sense to you guys, Arvind and Rohan?
Yes, Professor.
Cool. Okay, great. Well, let me know if any other questions pop up. All right, so I'm actually in a different time zone right now. So let's see here. It is 3:21 over there. So we have about 40 minutes left, I think, 35 or 40 minutes. Right, okay. All right, so yeah, those are the high-level course overview items. And really now I'm excited to kind of get into some real material. So unless there's any other questions, feel free to hop in, Rohan and Arvin, if other questions pop up or if I missed anything. But I think what I'll do now is I'll hop into the first module. All right, cool. Okay, let's see here. Man, I really miss being able to see everyone's faces. It's like it's more fun because I can see if you guys are following along or not, right? I don't know. At home, you could be scowling in disapproval, and I wouldn't know, or you could be, really, I don't know. You never know. I'll assume everyone is smiling and happy with the progress so far. All right. Okay. So this is our first module. The module is called the original problem. We call it that because you're going to work on the first computer vision problem. Really, maybe there's a couple earlier ones, but this I would say is a great example of one of the very first times that people tried to do computer vision. So let's check it out. So this is the repo. You'll find most of the stuff here. And let's talk about the people who did this. So here are the three people kind of in our story. So we have Marvin Minsky, Seymour Papert, and Gerald Sussman. So at the time, this is the 1960s at MIT. So Marvin Minsky, he is kind of credited today as being one of the fathers of artificial intelligence. He was a researcher back in the 60s. And Seymour Papert, he was also a researcher. He invented a whole programming language. I forgot what it's called. He's done a bunch of really cool stuff though. So they were heading the MIT Media Lab and the MIT AI Lab, and they hired an undergrad named Gerald Sussman, and they hired him to do this really interesting summer project that we're going to call the 1966 MIT Summer Vision Project. And let's have a look at what these early pioneers, these kind of, fathers of artificial intelligence, or the early researchers, what they tried to do. So let me zoom in just a little bit. Let me know if this is too small. I can't zoom in too much further. Okay. Are you guys able to read that? This is a little bit smaller. Is that coming through okay?
A little bit zooming is required.
A little small? Yeah, I gotcha. Okay. For some reason on GitHub, when I zoom in, it barely gets bigger. That's depressing. Okay. Maybe I can figure out something better. It's because GitHub changed how they view READMEs and they're no longer full screen. I wonder if I could do this. No, do that. No. Okay. All right. Well, I'll read this part to you. Check out the repo later when you have time. But I can't make that one part bigger. But what we're looking at here, I know it's a little bit small, apologies. This is the abstract from this summer vision project. And the goal was to construct a significant part of the visual system. The particular task was chosen partly because it can be segmented into subproblems, and it will be a real landmark in development of pattern recognition. So really, these researchers at MIT, they thought, oh, someone put a good point here, class is at 3:45. Thank you. Yeah, I was wondering about that actually. So yeah, we have 20 minutes. Great, thank you. Another challenge of remote. Okay, so their goal for the summer was to create a significant part of the visual system, which is a pretty bold goal. And they assigned this to an MIT freshman, Gerald Sussman guy. And here was their first goal. So during the summer, their goal for July, they said, okay, let's do some analysis on a set of scenes of non-overlapping objects of balls, bricks, and cylinders. And what they were trying to do in July was to write some code to develop a computer vision algorithm that could figure out if an image contained a ball, a brick, or a cylinder, which to them sounded apparently pretty easy, right? Because they had an undergrad try to do it in a month. So that was the goal of this first project. For August, what their extension was, they're going to handle other kinds of objects, so cluttered backgrounds, different kinds of cylinders, basically adding clutter to their image. So what I want to start thinking about is, just how hard is it to achieve these goals? How far have we made it since that summer, like 50 years ago? How easy are these tasks today? That's what I want us to start thinking about. How hard is this really to do? And my hope for you is that in about 3 weeks, you'll have a good sense. And by the end of the semester, you'll have a really good sense using some modern deep learning techniques on exactly this problem. So what we have here then for you is the data set. And we'll show you the data set in a minute. And we're kind of getting into what the first programming challenge is going to be. So here are some images, right? We've got images of, and we'll show you some more shortly, but we have images of bricks, balls, and cylinders, just like you see here. And your whole job in Programming Challenge 1 is to write some code that can tell them apart. That if I give you an image and you tell me, hey, that has a brick in it, right? So I don't know if that sounds easy or not, but you'll find out. You'll find out how easy or difficult it is. Okay, so in this repo, you'll find a number of notebooks that we'll go through in the course. And let me just go ahead and make a disclaimer right now at the beginning. So the tempting thing to do, and something that you'll find us doing in this course, and it's going to be a little annoying first, is we're going to give you this challenge, and it's going to be kind of big and open-ended, and we're never going to tell you exactly how to do it. So some students at the beginning go through the first few lectures, and they're like, okay, when are we going to really learn how to solve this challenge, right? And the answer is actually never. So I'm never going to tell you how to actually do it. And that's on purpose. It's because I want you to figure out a way to do it. There's a lot of ways to solve this. And you'll see in the grading, we're setting the grading nicely, so it's you don't have to get them all right. But you have to do at least a decent amount of progress, basically. But please don't just sit and wait for me to tell you how to do it, because it will never happen. The TA won't tell you either. But what we're going to do in these first 5 or 6 lectures is we're going to cover some of the big early techniques in computer vision, edge detection, things like that. And it'll give you some hints, So the things that you learn in lecture will help you, but it's not going to be the whole thing. This is a graduate level course. We're expecting you to show some creativity to find your own solution. So that's going to be a big part of it. So don't wait until you have all the information to get started, is what I would say. So this is the outline for the different notebooks we'll cover. We'll hop into one in a second. And yeah, I think we're almost ready. Yeah, let's see here. So let's see here. I'm going to hop into a Jupyter Notebook in 1 second, but actually let me discuss grading first. Yeah, okay. So please review this later as you have time, but here's some more images from the data set. We'll show you these are the easy examples. We'll show you medium and hard in a second. But let me show you how grading works real quick. So your overall score is going to be based on your accuracy. So we're going to give you 4 different levels of difficulty. We're going to give you easy, medium, medium 2, and then hard images, basically. And your overall accuracy is going to be a weighted average of your accuracy on each of those subsets. And then we're going to take all that together, and then we're going to put it on this scale, basically. So if you get 60% or higher, then you automatically get a 10 out of 10. So we're grading this pretty nicely. You don't have to get everything right. And then we have a different grading scale that slides, basically. So that's how you'll be graded. And just remember, we don't have to have perfection, right? And even if you have really low performance, we'll still give you a 4 out of 10. So just keep trying things. Don't give up. And getting 100% is really hard if no one's done it. We're going to use deep learning on the same kind of challenge at the end of the semester, and we'll get very close to 100%. But really, anything over 60 is very, very good. So with that said, let's go ahead and hop into a Jupyter Notebook. I have some more instructions on setup. If you have any questions on setup, please post those on Piazza. But with our last 15 minutes, let's hop into a notebook. Okay. So to launch the notebooks, I have some instructions. You have a little bit of installation you'll have to do, but to launch the notebooks, you just Jupyter Notebook to your terminal. I'm going to do that now real quick. And don't worry about this too much right now. We can ask on Piazza. We'll get you set up. But I'm going to go ahead and launch a Jupyter Notebook. You can't see this part of my screen, but into my terminal, I'm launching a Jupyter Notebook. And that's just a local server that will let us run the code inside these notebooks. So hopefully this is coming through, and you can see the different notebooks that are in this repository. There's 6 notebooks. So I see a great question. Are the notebooks part of the programming challenges, or are they for learning purposes? So they are for learning. So you'll actually end up submitting a .py file, a script, not a notebook. So the notebooks are for learning purposes, and you can use them for experiment. But the notebooks are your main lecture notes. So good question. Okay. So we have a notebook that describes the challenge in a little bit more detail, and I want to show you that first real quick. So here I am in a Jupyter Notebook. And in case you haven't seen one before, a Jupyter Notebook is just a really cool way to combine code with text and images, right? So it's a dynamic, so we can run code in real time inside this environment. But I can also put text and images and all kinds of stuff in here. So that's what we're looking at here as a Jupyter Notebook. So the main thing I wanted to show you in this notebook real quick, this notebook has an overview of the challenge and all that good stuff. But I just wanted to show you the data real quick. So these are the easy examples, like I said. So your job is to figure out if these are bricks, balls, or cylinders. These are the medium images. So you're starting to see a little bit more complexity. So here's a brick, but there's a book in the background. Some of these are not as well lit, so this is kind of darker image. Some of these a little bit harder. The book that's in the background is the deep learning book for this course. It's a really good book, so just in case you were wondering. And here are the hard images. So the hard images, man, this is why you can see that getting 100% is pretty challenging. So here's the brick, but look at all the clutter, right? Here's a ball, but it's sitting in a cup. It's kind of crazy, right? So I want to emphasize that you can achieve a perfect score on this programming challenge and miss all the hard images. So don't feel like you have to get all those right. These are here mostly just for you to stretch a little bit. And we'll come back to this data using deep learning at the end of the course. And you'll see what deep learning can really do on this kind of data. Okay, so I've got a little description of the grading and stuff in this notebook. Last year, we did a $10 gift card for whoever had the highest score. So one other cool thing, just to make it fun, again, don't feel pressure to be at the top of the leaderboard. Our auto grading server does have a leaderboard, so you can see how your score ranks. Again, if you get a 10 out of 10, great job. That's a perfect score. Way to go. You'll see on the leaderboard some students want to compete and push a little bit further. And if you do, that's great. Feel free. We offer this reward just as a fun kind of thing. So the first place, we might do a Starbucks gift card, although with coronavirus, I think an Amazon gift card may be more appropriate that we'll send digitally. So we'll figure out if we want to change that. But we do like to offer a little bit of a prize for the top score on the challenge. So, and again, like I said, if you score over a 0.6, then you're going to get a 10 out of 10, and that's great. Good job. You've done well in this course. If you want to push harder and really learn a little bit more and get a little deeper, then we do offer, you'll see the leaderboard, how your score compares to your peers. And yeah, we offer just a little bit of a prize. Okay, so let me hop into our first actual lecture notebook. So we have 10 minutes left, perfect. And this is the first lecture. Some of your reading tonight or over the next 2 days will relate to this lecture. So here we are. This is our first lecture, and it's on something called Roberts Cross. And we'll start to get into using the notebook and all that good stuff here. So let me go ahead and hop down to kind of real action real quick. Let me hop down to, okay, yeah, just some real quick. But let me first back up just to get us thinking about a question. So here we go. Okay. So here are some images, some videos in this case, but you know, what I've just told you is, hey, you have 3 weeks to figure out how to decide if an image has a brick, a ball, or a cylinder, right? So let's start thinking, okay, you know, we're going to be using Python, and some kind of low-level Python. So you're going to be using pretty primitive math. You're going to be using math like you know, subtraction, addition, stuff like very basic stuff. You know, you'll be using something called a filter, but very basic. So let's start thinking about how we can get information out of images like those, right? What can we do? And we haven't really talked about how these images are represented on a computer, which we'll do that in 1 minute, I promise. Before we do that, though, let's just kind of go back in history again real quick, and I'm going to pull up one more person from just a little bit of historical analysis. So there's this guy named Lawrence Roberts, and he was another very early computer vision researcher, and he published some work that you'll be reading. And he proposed a way to use math to find the edges of objects in images. So as you can imagine, like, you know, how should I figure out this is a brick? One idea might be to say, okay, can I find the edges of this, and then maybe do some math about the shape of the edges, maybe something like that, right? So that's a high-level idea here. And the first question, though, is how do we use some mathematics to find the edges of objects? So let's get into that. So Lawrence Roberts proposed a way to do that, and let's look at what he proposed. So before we do that, let me just run a little bit of code here. So here's our first cell that I'm going to run. And if you look at my Python code, it says pylab inline with a little percent sign. So the percent sign in IPython or in the Jupyter Notebook, it's called a magic function. And what this does is it's going to import some libraries for me. So I want to use 2 libraries to start out with. One is called matplotlib and one is called numpy. I'm going to use these libraries to import images, to do stuff with them. So by running this line of code, I can import those libraries. One way to run this little cell, this is called a cell, this is another cell down here, is to just press the run button. I can do that right there. If you're a little more experienced and want to look like you know what you're doing, the cool shortcut is Shift-Enter. If you press Shift-Enter, it will run that cell for you. You can also press Control-Enter, and that will run the cell in place just as many times as you would like. So that actually ran that Python code. So now what I'm going to do is I'm going to actually import an image. So I'm going to use this function called imread, and I'm going to load up one of our images. You won't have these images right away. You have to run a little script that will download them. And we have instructions for that in the README. You'll see that. But once you download them, you have to point your tool or your code to look at the right image file. And just note here that some of you that are on Windows, you may end up having to use backslashes. Oh gosh, okay, here we go. Is that screen share still coming through? I accidentally minimized. Is that still coming through, Arvind and Rohan? Perfect.
Yes,
thanks so much. Okay. So you may have to experiment with this line. This might break. So just be ready to experiment a little bit. But what I really wanted to get into with you real quick. Okay, cool. There we go. I just added a couple new cells. This IM thing, right? What is this IM thing that I just loaded? So let me just experiment with you for a second. So this IM thing, if I type IM and I press Shift-Enter, I get this big array. This is it's called a NumPy array. And yeah, what are these numbers, right? What are all these numbers that we're looking at, right? If you've done any kind of image processing before, you might know that these numbers are actual pixel intensity values. Yeah, and Austin Simple said RGB values. That's right. Good job. Awesome. Cool. So yeah, these are the RGB intensity values. Does anyone know, and just out of curiosity, so, well, actually, let me show you one more thing really fast, actually. So I'm going to do something called, look at the data type. I'm going to do im.dtype. Okay, cool. All right. So I'm asking Python to tell me, hey, what is the data type of this array? And it says uint8. Does maximize the screen? Yes, thank you for asking. Let me see here. Okay, let me see if I can get this any bigger. Okay. All right, is that better? Hopefully you can see a little better now. Perfect, okay, great. All right. Thanks, all right, awesome, cool. So throw it in the chat window. And actually, Arvin and Rohan, do you have an opinion? I noticed that some people are chatting to me privately, and some are chatting to the host, presenter, and panelist. I guess they should do host, presenter, panelist. Would that work the best? Okay, cool.
Yes.
So, yeah, if you know the answer, what is a uint8, right? So what does this mean? If you know the answer, please chat it to the host, presenter, and panelist. 8-bit integer, yes, perfect. Yep, a couple people got it right, fantastic. And then Sean Hayes, yep, perfect. Okay, awesome, great. Okay, so this is a certain kind of data, a data type that we're going to use here. Does anyone know what is the largest number that you can represent using unsigned 8-bit integers? 255, yep, so yes. So Subham, sorry if I mispronounced your name, so 255, perfect. Yep, Adita agrees, cool. So if this makes sense to you, great. If not, don't worry about it too much. What I'm kind of getting at here is we're using a certain kind of data type, and the biggest number possible is 255, right? So if you look at this number, so these first three values, this is a red, a green, and a blue value. And the biggest possible value I'm telling you now that you could have is 255, 255, 255. Does anyone know what color would correspond to a red, green, and blue value of 255, 255, 255? So I'm seeing a few answers, actually a bunch, great, yep. So some of you got it right, some of you got it wrong. I see more got it right than wrong. We probably want to experiment with a polling feature at some point. We used to do that a little bit. Actually, we'll get into that. Let's discuss that, Arvin and Rohan, in our wrap-up meeting after this. So the answer is white. So if we have 255, 255, 255, this will be a fully white pixel, and 000 is black. So what I'm trying to get at here is this is pretty close to white, and this is actually the upper left pixel. Let me show you what I mean. So I'm going to show this image now. So there's a method called IamShow that shows images, and I'm going to pass in the image to it, and it will show the image. Here it is. Let me make it a little bit bigger. I will in 1 second. But that little value we were looking at, that is the RGB intensity value. It's the color of this upper left pixel. That's what we were seeing. So let me do one more thing real quick. I'm going to show you how to make this a little bit bigger. So I'm going to use something called a figure. So I'm going to type figure, 0 comma. So when I use this figure function, and it's part of what's called matplotlib, I have to give it a figure number. I'm just going to give it a number of 0. That's not too important. But what I can do next is I can give it a size. So let's say that I want my figure to be 9 by 9. Then I can press enter again, and it should make it a lot bigger. Yeah, there you go. So here it is a lot bigger. But that's our first image. So there is a brick. So pretty exciting. And just one last thing I want to look at here. Okay, cool. Okay. So we can display our brick. That's exciting. Yeah, two more things I want to look at here, actually. So the first one is this. So if I run im.shape, right, the result I get out from this image is I get 256 by 256 by 3. So yeah, so in the chat to the host and panelists and presenters, what does this mean? Why is the shape of this array, that is our image, why is it this dimension? Why is it 256 by 256 by 3? What does that mean about our image? Yeah, so I see an answer already. Awesome, cool. Yep, so this is the height, the width, and the color channels. So let me ask you guys one more question. You can answer via chat. What would the dimension be? So this is a color image, right? What if this was a black and white image? Does anyone know what would im.shape, what would the dimension of the image be if this was a color image? Yes, I see a couple folks are saying 256 by 256 by 1. So that's right, yeah, because this holds the color information. Okay, so if that makes sense to you, great. If not, don't worry about it too much yet. And let me show you one more thing real quick. So I'm going to show you a histogram. So here is a histogram of our image data. And what I've done here, right, is I've plotted the number of pixel intensity values for each intensity. Basically, we're plotting the height of the bar is the number of pixels that have. Is my
your audio just lost for 10 seconds.
Okay, but it's back now. All right, I think my audio loss is probably good time to end the lecture here. So it's already over. That was a fast hour 15. So yeah, we're just about out of time. So if you have any leftover questions, please ask them on the office or shoot an email to Arvind or Rohan. So we will pick up where we left off on Thursday. Please familiarize yourself with the course material, have a look at the notebooks, try to get notebooks running on your own machines. Let us know if you have questions, and we will talk to you guys on Thursday. And hopefully we will have a little bit better luck. If I see some questions coming in, please just shoot us an email, and we'll do our best to answer any other questions that come up. And yeah, we'll talk to you guys on Thursday. So thanks for coming today. I hope you have a good week, and good luck with all the virtual stuff. We're looking forward to the semester.